Welcome to this class. In this session, we are going to see how to prove that two matrices are inverses of each other. And the problem is, we have a matrix A given by 1/9. Then elements of the A matrix after multiplying by scalar 1/9, -8, 1, 4, 4, 4, 7, 1, -8, and 4. So we have to prove that the inverse of this matrix A is the same as its transpose. So to prove that two matrices are inverses of each other, you just have to show that the product of the two matrices is an identity matrix. So what you're going to do, you get the transpose of this matrix given A, and then show that if you take that transpose, you multiply by the matrix given A, you get an identity matrix. So that is enough proof to show that the transpose is the same as the inverse. So proof. So we are given that given A is 1/9, -8, 1, 4, 4, 4, 7, 1, -8, 4. Then this means that the transpose of this matrix, we still have a scalar 1/9. First row becomes first column, so we have -8, 1, 4, -8, 1, 4, and then we have 4, 4, 7. Second row becomes second column, and then we have 1, -8, 4. The third row becomes the third column. So that's the first step. So to show that A inverse is equals to A transpose is same as showing that A times A transpose gives me an identity matrix. So let's see. If we have A times A transpose, then the same as 1/9 into -8, 1, 4, 4, 4, 4, 7, 1 -8 minus +4 times 1/9, and then -8, 4, 1, 1, 4 -8, 4, 7, 4. And these two scalars, because it's a product, you just multiply them. So 1/9 times 1/9 is 1/81. So A times A transpose -8, 4, 1, 1, 4, -8, 4, 7, 4. And then this other matrix is -8, 1, 4, 4, 4, 7, 1 -8, 4. So let's now carry out the multiplication. So to multiply these three matrices, So we'll have A transpose is 1 over 81. Now it's always row by column. So we'll have -8 times -8 is 64. Plus 1 times 1 is 1. 4 times 4 is 16. -8 times 4 is -32. Plus 1 times 4 is 4. 4 times 7 is 28. -8 times 1 is -8. 1 times -8 is -8. 4 times 4 is 16. 4 by -8 is -32. 4 by 1 is 4. 7 by 4 is 28. 4 by 4 is 16. 4 by 4 is 16. 7 by 7 is 49. 4 by 1 is 4. 4 by -8 is -32. 4 by 7 is 28. 1 by -8 is -8. -8 by 1 is -8. 4 by 4 is 16. 1 by 4 is 4. -8 by 4 is -32. 4 by 7 is 28. 1 by 1 is 1. -8 times -8 is positive 64. 4 by 4 is 16. So A transpose is 1 over 81. Now 64 plus 1 plus 16 is 81. -32 plus 4 plus 28 is 0. -8 minus 8 plus 16 is 0. -32 plus 4 plus 28 is 0. 16 plus 16 plus 49. 81. This will be 0. This is 0. This is 0. This is 81. Now, because these are matrices, then you see inside this matrix, 81 is a common factor. So pull it out. So 81 over 81. And then 1, 0, 0, 0, 1, 0, 0, 0, 1 equals to A transpose. 81 over 81 is 1. So this is just 1, 0, 0, 0, 1, 0, 0, 0, 1. And you see, this is an identity matrix. So since the product of A and A transpose is an identity matrix, so therefore the A transpose must be the inverse of that matrix A. So hence A inverse is the same as A transpose. And similarly, you can show that if you take A transpose times A is the same thing as A transpose, still get an identity matrix. So that's how we prove that. And then there are other results about products of inverses. So theorem will state without proof, but they are not hard to prove them. So one, we say that if A satisfies the relation that A squared plus A minus I equals to 0, where A is a square matrix of same order as the identity matrix I, and 0 is a square null matrix of same order as A, then the inverse of A is equals to identity minus identity plus A. So that's one result about inverse matrix, that if the square of a matrix plus the matrix minus the identity matrix, you get a zero matrix or a null matrix, then this is how we get the inverse. And then theorem 2, that if A and B are non-singular matrices, of the same order, and actually all of them are square matrices, then A, B, the inverse of the product AB is the same as you change the order of multiplication when you are defining the inverse. So AB inverse is the same as B inverse times AB inverse, and A inverse raised power m is the same as A power m inverse for any positive integer m. So that's what we have. That the product of the inverse of product of two matrices is the same as getting the inverse of respective matrices, and you define the product in the opposite direction or opposite order. AB inverse is B inverse A inverse. Thank you.